Alright everyone, today we'll be taking a look at the Lua programming language, more specifically the Lua JIT actual version. Um, so Lua, I've known Lua for quite a bit now. I've never actually used it for anything big, but I know the language exists for many years now. I know it is quite a fast scripting programming language. I think it's better than Python, even though I tend to use more Python than Lua because I'm forced to. But yeah, so this is going to be another exploratory video where we try out a language. So as I said, there are two main versions, the Lua version and the Lua JIT version. This one was originally created and designed by these guys in Rio de Janeiro. Um, yeah, many years ago, like 33 years ago. While the Lua JIT came afterwards, it was designed by this guy, Mike Paul. It follows the Lua 5.1 version or something like that, and it basically does whatever the name says. Like it's a JIT version of Lua. Yeah, with tracing. Yeah, and besides that, it should be more or less the same, right? That's should be the only difference. Like the main Lua version tries to be implemented in NCC, while this one tries to be as fast as possible, I would say. So, um, yeah. So this is the main Lua website. Um, it has a lot of text, but if we go to like maybe the news, yeah. So the latest version is 5.5.0, and it was released just 2 months ago or something like that. While the Lua JIT version, is there a version? Well, I know it's like in 2.1 or 2.0, yeah. Um, so, but this version is compatible with the Lua 5.1, if I'm not mistaken. They could say that here, but apparently they do not. So that's yeah, Lua JIT 2.1. So this is the latest version for Lua JIT. So yeah, let's try it out. Um, I think I want to build it from source. Um, is only distributed. Okay, so it's actually only distributed as source code. That's fine, because I know that this can actually compile quite easily. So and fast, so it should be fine. Um, yeah. So here they define the prefix. So this is how we install it. We are going to use WSL, so we want the POSIX thingy. Okay. So this is the repository that we need to clone. I already had like a very old Lua JIT version in my WSL, but I deleted it. So let's do the installation from scratch. All right, so it is cloned. If we open that's not what I want. This one is what I want, I believe. Yeah. So I can already tell you that DNASM is the like preprocessor that does the conversion between the assembly that is written directly into the C files, and it does the preprocessing and converts that into actual function calls that just emit bytecode. Um, I actually know that from learning that a few days ago. Um, yeah, and I guess this is just the compatibility layer for ARM, and then we have MIPS and x86, x64, PPC, and all of that. So these are just the different CPU architectures. And this one, I suppose, yeah, it just does the pre-processing stuff, and it is written in Lua itself. Then I have no idea what this is. Okay. Then we have like a bunch of files, and this is actually the Luajit implementation, I suppose. And here we have a bunch of C files with a bunch of stuff, I'd say. Yeah, basically. So I guess that's basically it in terms of. I'm also like not going to go too much into depth about the implementation itself. Like, yeah, this is basically, yeah, the encoding of the instructions and all of that. We know how this looks like because we did something very similar a few days ago with the Forth compiler. So this is relatively familiar, this kind of approach. Okay. So, and then they also have this JIT thing, but in this case, I don't even know what they do, to be honest. Oh, this is still like function and s, I suppose. Yeah, move s. Okay, these are still instructions. All right, so they have a bunch of instructions then in actual Lua, and then they have this host stuff. Okay, this has the hash function, print hash. So I suppose this is like for the Lua tables and stuff like that, maybe. Or even the parser. Yeah, maybe the parser itself. Okay. So they have a bunch of code, basically. So let's try to compile it. Okay, the make file is actually quite small. It's not that large, like 175 lines. Here they have, yeah, they have a bunch of stuff. Okay, with the pref. Okay, my VS Code is jumping around. Yeah, they have gitlib files. They have the install. Pretty standard stuff, I would say. Okay. So if I do make an install, just to make sure I do not have anything inside my system. Isn't that how you write it? Apparently not. Okay. Okay, so I suppose it is uninstalled. And here they were saying for the installation to do make and then sudo make install. Okay. Can I do like make with O3 or like common? Okay. Do I have flags? I do not have flags. Do I have so phony does all. Can I? Okay, so this is false. This grabs stats. Which I don't know exactly what that is. Okay, and then just as -c src. Okay, so I'm just going to do what it says, but I would like to be able to configure the, for example, the optimization level, which is something that simply does not exist in this file. Apparently I cannot. All right. Yeah, I'm not seeing it anywhere. So this is just the files includes. Yeah, it just copies that sheet. Yeah, I do not think we can actually manipulate those flags. Okay. So I can only do make. Oh, let me actually do make -j16 so it's a little bit faster. Yeah, as you can see, like this stuff does not add any flags. Like those could be configurable, to be honest, but yeah. So this has done everything that it needed, and now I can do sudo make install. And what this shit is going to do, it's going to do a bunch of CTs, remove sheets. Symlinks. Okay, so it's going to do a normal installation, I'd say. Okay, that was quite fast. And now I should have Lua JIT in my system, right? So what's the name used? Okay, it's Lua JIT. Okay. So do I have Lua JIT in my system? I do. Okay. How do you even print stuff in Lua? Is it like this? Yes. Okay. So I suppose it's simple. I cannot do that. Is it exit? Is it like this? Okay. So it's Control D and it works. So now I have Lua JIT in my system. I can like create a test file .lua. What could we do like to test Lua JIT? I mean, we could do the same stuff that we did last video for the Gleam test. I guess so. So here they allow us to list bytecodes, strip debug info, keep debug info, generate 32-bit or 64-bit bytecode, generate bytecode in intermissing manner, set a specific module name, set a output type file. Okay, that's fine. Override architecture, override OS, so I can basically transpile to other architectures and operating systems. Alright, file name, use chunk string as input. Okay, so it seems pretty standard. So if I do something like this, in my test.lua file, I do print hello world, right? If I do that and then do test.lua, it does hello world. But if I list bytecode or something, what is it going to do? Alright, so if I don't provide a file, so I need to provide a library name. Oh, I need to first save or list bytecode, I guess. So if I do -p, oh, I need to provide the output. Okay, so what output can I say? Okay, I can say test.out or something. Okay, did it generate a file? Yes, it is. It generated this file. Let me open it anyway. Okay, so basically this generated bytecode, it has a bunch of stuff that is not able to read from the file. But here we can see the string and here we can see the function. And okay, this is null terminated. Yeah, so this is the entire string. And here I suppose like this is some kind of instruction. Okay, so it's actually not that much bytecode for this small program. So it's actually very reasonable. And we can already compare. We can already compare the time that this takes to run. So it's even faster than C, and much faster than Gleam, because Gleam yesterday was taking 4 seconds to compile an hello world, and Lua JIT is taking like 5 nanoseconds or microseconds, something like that. Like it's significantly faster than Gleam, so orders of magnitude faster than Gleam. All right, so that's cool. Do we I don't think we have the function in this built-in module control the behavior of JIT compiler engine. Okay, so these are the extensions. Is fully opposed compatible with Lua 5.1. Okay, supports all standard Lua library functions. Okay, so I think we should start from there by the standard library functions. And if we want to implement like the environment variable reader like we implemented yesterday, we probably need a way to get argv, right, or args. Okay. I'm not reading all of that. So environments, garbage collection, coroutines, we have closures. Okay, but this one is how to interface that with C, which I don't necessarily need right now. So let's search for Lua commands line arguments. Oh, there is a global table called arg, where arg0 contains the script name. Okay, so let's test that. So if we do print arg, we don't need to time it. Yeah, okay, so this has a table address. Let's call this args, like we named it yesterday. So this is args. Okay. So it's telling me, okay, named arg, but by the way, how do I print a table? Lua print table contents. Okay, so I can do a for loop with pairs, and then I can just print the key and the value. Okay, that's pretty standard, pretty simple. Let's see if it works. So for, and then I can do key value in pairs, right? Yeah, and then I can say arg do, and then I can do this stuff, and then ends. If I do this should print. Okay, so in the 0th element or 0th position, we have the name of the file, the Lua file. On the -1, we have the executable, right? And then if I provide more stuff, for example, get term, we get okay, so yeah, we get the first on the first element and the second on the second element. Okay, so I know that in that case I can do the following. So as a reference menu, do we have a switch statement in Lua? We don't. We have a case. The following. Okay, so these are all of the keywords that we have in Lua. So we have and, break, do, else, else if, and false for function if in local nil. So I do not think we have a switch case. All right. In that case, we'll be forced to use if, right? So if, and here we basically need to say, oh, okay, argv. How do I measure the length of the table in Lua? Okay, the length operator. This one, the length of a string is a number of bytes, that is the length of a table. T is defined to be any integer index n such that Tn is not nil, and Tn plus 1 is nil. Okay, moreover, if T1 is nil, n can be 0. Okay, so if I do something like print the tally of argv, oh, that's not it's actually arg, sorry. We get 2. And here we got 1, 2. Okay, but if I provide none of it, we got 0, which kind of makes sense. right? Kind of makes sense. So we can basically say if that is equal, how do you even measure equality? Okay, it's that one. Is equal to, or actually it is less than 2, we can do ends, and we can say the following: usage, we can even do, how do I do string interpolation? Lua string interpolation. Okay. So concatenation string.format for interpolation. Okay. So maybe you can use yeah, we can use string.format. I don't know if that exists or not, but we'll see. And then I can do that, and then I can say name, right? Or actually, yeah, I don't even need that. I can just say, well, I may actually need it. So let's say that. Okay. Then here I can say arg -1 and arg 0, and this should be that, right? So if I don't provide it, oh, I need this. Okay, if then, yeah. So if I remove this, this is the error that I'm getting. Usage luagit args lua get name. And I can exit actually. So do I have an exit function? Okay, let me see. This is exit loop, but I want to, okay, it's os.exit. Okay, so if I do os.exit 1, can I, like, for the codes, probably not, right? So exit underscore, is there any, okay, but this one is a interface. Yeah, I don't think we are able to do that. Okay, so let's use just one there and let's test it. So what was the, already forget, man. Was this one? No, was it like echo? Okay, yeah, it returns 127. If I do 0, if I do this, that, you get 0. And then if I do this and I get 1. Okay, so it's working. So this checks if we have enough arguments in the call. And here I can already see that we can get environment variables, right, with os get env. So I guess we can just do os. Well, actually, if this is less than 2 or arg 1 is not, how do you even define not equals? Is it like this? Nope. Is it probably this one? Yeah, probably that one. So not equals get, we can do this. So if I say something like this but push 1, this is going to fail, right? But if I do get 1, this is going to pass. Okay, so here we already know that the first argument is get. We can basically just extract the last one, arg2, and we can just say os.get env, like so, and we can just print it, right? And we can even say the same that we did before, something like this. Actually, we need an equals here, and then we need that. Okay. So if I do this, you see, like, it's so much easier than Gleam. Did you see how fast and simple and easy this program was to implement? Like, let's remind ourselves of the bullshit that Gleam made us go through. Okay, so if I go here and then here, source and here, like okay, but here is no longer the implementation. But yeah, for Gleam the implementation was significantly harder. Right. So if I do Gleam, I can go here probably. God damn. Okay, Gleam. Can I? Okay, Gleam programming language. And then if I go to docs and then I go to their own like example, and here you can already see like this shit is going to install a bunch of dependencies in crates, which is absolutely ridiculous. And then this is their implementation, right? Compare this implementation, compare this shit with this shit. Like this is significantly simpler, right? Yes, if I wanted to, I could do like string formatting here. So string.format. And here I can just provide s equals s, right? And then I can do that, and then that, and that's it, right? So, oh, it's a lowercase s, okay. You see, like, it's so much simpler, right? And I'm also using like the format stuff that they have here with like specific function for formatting. Like, I mean, you can already see why Lua got so much popularity, right? And why Gleam is like only for nerds that want a toy language. Yeah, I mean, like Lua is far superior. I mean, is there anything else I can implement in Lua like very quickly? Or should I just explore random shit from Lua? So they say they have these extension modules for LuaJIT. So LuaJIT extends the standard Lua VM with new functionality and adds several extension modules about functional enhancements and not about performance enhancements, such as the optimized VM, the faster interpreter, or the JIT compiler. Okay. Built-in extension modules. LuaJIT supports all bitwise operation as defined by Lua BitOp. Okay. This module is a LuaJIT built-in. You don't need to download or install Lua BitOp. The Lua BitOp site has full documentation for all Lua BitOp API functions. Okay. The FFI adds support for 64-bit bitwise operations using the same API functions. Please make sure to require the module before using any of its functions. Okay, so apparently we can use like these extension modules by just doing a simple require. Okay, so if I do that, this should already give me an handle to this extension module from LuaJIT, if I understood it correctly. Allows calling external C functions. Okay, that's already, I'm familiar with that. Then we have this JIT compiler control. The functions in this module control the behavior of the JIT. This can actually be interesting. CAPI extensions. Okay, and then we have an integrated profiler. Then we have some enhanced standard library functions like XP call. Any arguments after the error function to the function which is called in a protected context. Okay, this is interesting. Then you have loads. ASCII are handled transparently by the Lua source code parser. The use of UTF-8 in identifiers and strings is kept at the start of the, okay. Then we have another load, add a mode parameter. As an exception from Lua 5.2, the functions load string, load file, and new load as an optional mode parameter. Okay. Then we have toString. Oh, this one was also a very pain in the, like a big pain in the ass to be able to print stuff with Gleam, right? Because we were not able to print structures. So how do you, like, what is the comments, by the way, for Lua? Is it, oh yeah, it's this one, the assembly style comments. Okay. So if I do something like toString of arg, what is this going to do? Okay, it printed the table as is. It didn't really do anything to it. toString. Yeah, and I cannot call it like that. So toString needs to be called with an argument. So, but I suppose like the print function already calls toString inside because it's printing the same stuff. Okay. But we already know how to print a table, right? We can just come here and say for key value. What was it? Equals pairs, right? Pairs of the table T. We can even create a function for it. We can say yeah, let's make a function like table to string or something. And we can say that this is a function, or yeah, they'll also allow us to define it like this, right? And I can define a local function. Yeah, something like this. So how hard is it to implement something like this? So if I have a table like this, so do AND, of course. So here I have for key then, but here I probably need like a s, like, so a string, like an empty string to begin with. Then I do pairs, do ends, right? And here I can just say something like s concatenates, or s is equal to s concatenated with I can even use like string formats. Why not? Well, let's do the following. Key concatenate equals concatenate value, right? And then I can return s, something like this. So this should work. Like if my intuition is correct about this language, this should, okay, expected near equal. How do you even do, like, I already forgot how you do for loops. God. Lua for loop. Isn't it? Huh. Pair. Let me check. Okay, are you going to? Okay. Oh, it's in. Okay, it's not equal, it's in. Okay. And expected. What you want from me? On line 21, why did you want me? Huh. How do you define, by the way, how do you define a function? Lua define function. Function, my function, and then the parameters. Oh, it doesn't have a do here. Okay, it doesn't have a do. Okay, so yeah, we were able to implement this. We can add a new line at the ends, like so. Yeah, and we have something like this. So it's very easy to like pick into objects, or in this case tables, and be able to work with them. Much easier than Gleam, at least at the first glance. At least at the first glance. Okay, but let's go back to the extensions that we were trying to test. So we have the bitwise extension, right? And here, yeah, it was this one. Oh, it's basically that bit.b naught is basically what they had here, right? Yeah. So uh, uh, don't they have, oh, they have b XOR. Okay. So if I do something like b XOR, and how do you use this shit? Uh, oh, here you can define shortcuts. Okay, I don't really want to. So I guess you just provide the numbers, apparently. So if I do that, something like this and something like this should give me 0, right? Oh, let me comment these codes. Yeah. If I do this, yeah, it gives me 0. But if I do uh, something like this should give me FF, or in this case 255. Okay. Okay. This is pretty reasonable, I would say. Like, it doesn't, well, we have 2x. This one may be interesting. So if I do bit dot 2x, this should now print ff, maybe? Yeah. Okay, but 2x returns a string. Okay. Okay. Interesting. Yeah, and then we have a bunch of stuff. We have roll, roar, right rotation. Okay. All of these 16 element files are considered true. Okay. Okay. Interesting. All right. So this extension is something that exists. I don't know why it is an extension. Is not part of the standard lib, but I guess that's how it works. What else? So we add this to string to number. String to number conversion. This one it may be interesting. Let's say to number. So if I do to number of, I don't know, nan, is this going to work? Yeah, it will send me nan. If I do something like a really huge number, like I don't even know if this is enough. Okay, it prints me like that. But well, I don't know how to format a number. I know that Lua has like 52 bits of precision for integers. So yeah, I don't know how much that is, but it apparently is more or less okay. Okay, so here I can generate portable bytecode with string.dump. Okay, debugging info. So it's the same as dash p. So what if I say string dot dump of oh, but this accepts a file. Huh. Okay. So I'm not going to test it right now. So I can allocate a precise table. This may be interesting for like efficient code, right? I can clear a table. Pseudo random number generators. So here we can do the IO stuff for file. I assume these files are like the POSIX, like, or the Unix files, right? Because anything can be a file. I suppose it would be nice if it would work like that. Okay, and then we have a few extensions. from 5.2 as well. So it's not only 5.1, we also support stuff from 5.2. We get a bunch of stuff, load file, we get log formats, read lines. Okay, that's okay. Then we have pairs and iPairs, check for pairs and iPairs. Okay. Table pack and mpack. I want to test this coroutine stuff. Yeah. Let me test what this coroutine is exactly. So I'm forced to yield. I already knew that. So this is not like Go, that the coroutine just runs and you don't need to worry about yielding. Here you are forced to yield. So let's create a function. Let's take a function and this just like generates ints, for example. And here I can accept an n. And so this is going to do for I equals 0 up to n. I don't know if this is the syntax, but let's see. I can do something like so here create, resume. Okay, here I probably need yields the most, right? Cannot be running a C function. Any arguments to yield are passed as extra results to resume. So let's try that. So if I do return, or actually coroutine, I'll even type that. Okay, routine dot yields. I cannot type today. Okay, yields, and if I yield I, right? Here I can just do end. If then I do interesting. Okay, if then I do something like print. Oh, I need to create a coroutine. Okay, so if I do coroutine dot create, and this is going to create me like a coroutine. I can say this is local. Okay, local. And then I need to pass the function. I can say something like ints, right? Sure. And then, so it first does co-body, that, then does foo. All right, and then it returns that co-body, returns. Okay, I'm starting to get a grasp of how this works. So if I do coroutine dot resume of C, what is okay? I probably need to require. Oh, I don't need to require stuff, but my for loop, okay, is fucked. So Lua for loop range. I from 2. Okay, but why is it complaining then? What are you complaining about? For limit must be a number. Oh yeah, because I never called it with anything. Yeah. So here, huh? Oh yeah, I see. So here in the resume stuff, I need to call it with the actual. So if I say 10, attempt to yield across C call boundary. in function yields. Huh. So let's copy this example for now, and then we try whatever we were trying to do. So we have this stuff. Okay, but this worked. This worked. So why didn't my thing work? So let's comment this out and let's try to bring back my thing. So if I do something even simpler, and I just do that, right? So I create a local, like a local coroutine with this function. I can even simplify it even further and not pass any parameter there. Just do that. So, okay, so this printed true and 0. So if I pass n here, like so, and here I say 10, okay, it worked. So why wasn't it? Okay. But if I keep doing resume here, then okay. Can I like pass 10 on the first call and then on the other calls can I just not do it? Yes, I can. Okay. So I just need to call it on the first one. Interesting. So if I do something like, so we have 1, 2, 3, 4. If I do 5, okay, if I do 1 extra, it still works. So it's inclusive loop. Okay, it didn't return anything. Okay, so cannot resume that coroutine. Oh, I see, because here the loop ended and it then jumped there. It continued and yeah. Okay, okay. So interesting. So how do I know? Like, so coroutine resume. Let me read the documentation. Starts or continues the execution of a coroutine call. The first time you resume a coroutine, it starts running its body. The values are passed as this arguments to the body function. The coroutine as yielded resume restarts it. The values val are passed as a result from the yields. Okay. If the coroutine runs without any errors, resume returns true plus any values passed to yield. If the coroutine yields or any value returns by the body function, terminates. Okay. If there is an error, resume returns false plus the error message. But how do I know? Oh, here. Returns the running coroutine or nil when called by the main thread. Okay. Returns the status of the coroutine call as a string running. If the coroutine is running, that is called status suspended. If the coroutine is suspended, in a call to yield, or if it has not started running yet, normal. If coroutine is active but not running, and that, okay, this is what I want. Okay, so if I do something like for like this, can I have infinite loops in Lua? Lua infinite loops. While true, okay, I can do while true. While true, do that, right? And I can end, and here I can get basically first if coroutine dot status of this is equal to that, then and I can basically break from the loop, right? Basically do that. Otherwise, I'm just going to keep calling it. right? And here I can ignore the first one. I can get the number. So I can get n, something like this, and I can just print n, right? So these should like keep generating numbers until it basically terminates, and then it basically ends the program. Yeah, yeah, interesting. That's very interesting actually. So it basically kept going until it returned nil. So here one thing I could do is basically do -1, and here I could just return n, and in that case it will just finish on 5. Yeah, so I can just manipulate my generator to behave the way I want to. Okay, but can I do something like this? So if I have a local function, right, if I have something like this, can I extract this function into here, and can I just pass it there? Or is this not allowed? Oh, it is allowed. So I don't really know why it's errored out previously. Maybe I did something wrong. Well, I was not really declaring function like this. I was actually declaring it like this. Yeah, it still works. Okay. Okay. So that's quite a nice feature. And again, this was not working on Gleam. So Gleam has the benefit of having like an entire Erlang VM on its ends, and it was still not able to give me working coroutines. Okay, keep that shit in mind. Okay, keep that shit in mind. All right, so let's see. Let's keep reading. Maybe there's something extra that is interesting to try out. Well, let's just make sure we've gone through okay, this one, it's architecture, OPT, introspection. Okay, so this is not really necessary now. Oh, we have also this, so we don't need this, to be honest. This one we already used. This one, I don't know what it is. Creates a new coroutine with the body f. F must be a Lua function. Returns a function that resumes the coroutine each time it is called. Any arguments passed to the function behave as the extra arguments to resume. So what's this? I don't understand what this exactly does, to be honest. Like create the wrap function also creates a coroutine, but instead of returning the coroutine itself, it returns a function that when called resumes the coroutine. Oh, that's actually interesting. That's actually interesting. But what happens? Unlike coroutine resume, coroutine does not catch errors. Any error is propagated to the caller. Huh. So if I do coroutine wrap here, basically I'll have a wrapped function. I cannot do this shit now, and I cannot do this shit as well, right? And here I can just do n is equal to this, and I can just call the wrapped coroutine and use it as a function, probably. Okay, attempt to perform arithmetic on call local n. Oh, do I need to say this? No. What if I say something like this? No. So how do you use... Okay, can I have an example of coroutine wrap? That's right. Well, they have it on Roblox, I guess. Roblox uses Lua U, which is slightly different, but okay, but so coroutines as iterators, so that's more or less what I already did, right? But I would like to like see you use... Okay. a function that when called resumes the coroutine. Unlike the original resume, that function doesn't. It's simpler to use than coroutine create. It gives us exactly what we need from a coroutine, a function to resume it wherever. It is also less flexible. There is no way to check the status of the coroutine created. Cannot check for errors. Okay, but then why is this code not really working? So here I have coroutine wrap. Yes. Like, can't I? Maybe it's because I have an infinite loop and it is like Stack Overflowing. Not really. Attempt to perform arithmetic on local n. Oh, I see. Because I need to provide a number. Yeah, I need to provide, of course. But in that case, yeah, I cannot check if this is running. Huh. So if I use wrap, the only way to do this kind of shit is to write return nil at the end or something, and to basically do something like this shit, and do if n is equal to nil, then break, right? And that's basically the only way I see we can do that. Why did it do? Oh yeah, because I'm using m instead of n. Okay. It went up to 10. Okay. And yeah, I can say local. Yeah. I guess it also works. It's a slightly different way of using coroutines, but it's fine. Yeah. Maybe the other one gives you more flexibility because it allows you to test like the status of a coroutine. It allows you to see if the coroutine is running and all of that. But this one, I mean, you end up writing the same amount of code, I would say, but it's more visually pleasing, I would say. All right, so that's also very interesting. So I guess we finished. Yeah, we finished all of the possible stuff we have for coroutines. So let's go back to here. So this is string defined, removed that. Okay. Then we have extension from Lua 5.3. Okay, file reads. That doesn't have that much. Oh, coroutine is yieldable. That's another one. Okay, we don't have that. So let's search for it. These docs are prettier than the other ones I was reading. Oh, they also have coroutine close. And they don't really have, okay. They don't have documentation for this, okay. That's bad. Let me see the Roblox documentation. Maybe they do have it here. Okay, is yieldable. If the coroutine this function is called, within can safely yield. Okay. That's pretty straightforward. And then, yeah, there are no more functions. What does this close do? Closes and puts the provided coroutine in the dead state. Okay, so it just kills the coroutine. Okay. Yeah, and that's basically it. All of the extensions and everything we went through. Yeah, and that's basically it. So I mean, it was a very pleasant experience, to be honest. We can check the profiler. JP, what does JP do? Underlying JIT.p module to get chase run is to get CPU user profile by function name. Okay, that's actually also interesting. If I say minus JP, no samples collected. Should I do more stuff? No samples collected. So maybe it doesn't work with coroutines. Stack dump. Huh. Oh yeah, okay. So I need to require this sheet and then okay. Okay, but if I do something like stack dump or something, yeah, it doesn't really want to do anything. Well, yeah, this is not really great. Let me delete this file. So let me create a function really quickly. Let me comment this out. Create a function, something like local f, or actually function. I don't know, something like that, which is just going to do from that all the way up to 10,000 new ends. We can have like a local n equals 0, n is equal to n plus I, and then I return n. If I do something like this, let me just print, is this going to be able to collect samples? No, it's not. I don't know why it's not collecting samples. Maybe I'm not using it properly. What if I do VM states? No. So let's search for it really quickly. Git profiler. No samples collected. There isn't really anything. Okay. So if I do example, are you going to give me? Not really. Okay. Where was I? Well, it would be nice to test something, but maybe, I don't know. Maybe it needs more stuff to actually be able to collect samples. Well, I can manually do it, right? So if I do something like this, like that, and then that, is this going to be able to do something? Well, it still says no samples collected, which is interesting. I can also try this. If I say that and start, separate routine, the try argument. Okay. And I can just stop. Okay. Here I must provide f, I suppose. Can I just do new here? No. Then I need a function, and this is a callback, and this requires thread samples. Okay, I can just copy this. Okay, I can just print those, I guess. Thread samples and VM state. here I can just provide my callback. Okay. So this didn't really print anything. Yeah, I suppose that's the issue. Like I'm not running like a big enough chunk of code for it to be able to profile. It could be that, but I'm not really sure. Yeah, is there anything else relevant to explore? So this is FFI. That's like you just write C code and it does the stuff, so it's okay. Callbacks are slow. Okay. Can inline or optimize across the language? Very okay. So we should avoid doing this repeatedly, I guess. These callbacks and p calls and all of that. Okay. So I think that's basically it, right? So I liked it, to be honest. Like it's a significantly better language than Glim, in my opinion. Um, I mean, it's just better. It's just better. I don't know. They have like different principles, but at the end of the day, what you expect from a language is for it to be usable and to work well, right? So I liked it. I liked it, to be honest. Is there any? Oh yeah, so it's compatible with a bunch of stuff. So it is able to JIT compile to a bunch of different CPU architectures and operating systems. Yeah. So it's in the home. Like we have. Oh yeah, we have an extension for through C coroutines. We haven't explored it. But note that Calico does not depend on Lua JIT and works fine with plain Lua. Okay. So what's the difference between Coco and the other one? Can I... It runs on Linux, BSE, Mac OS, and Windows. Any else you can find. Okay, but where can I exactly... Lua JIT, Coco. Yeah, this is the same website. Oh, but this one is still single-threaded. Okay. The website is just super slow. And it is an HTTP website instead of HTTPS. Okay, I'm not counting. But yeah, it's still single-threaded, so it's still the stuff. Oh, okay. All coroutine functions should be fully upwards compatible. So I've been using the Coco stuff. Okay. Okay. And this is still single-threaded in that case, right? From what I understood, it doesn't really say multi. No. We have like pthreads. Also no. So I suppose this is yeah, this is the same file. Like since this says single threaded here, I'm gonna suppose this is single threaded, right? So we still do not have like actual like multi-threaded, like even with POSIX threads or something, coroutines like Erlang or Golang Ev. That would be nice. I think that's the only thing missing in this language. Everything else is pretty easy to understand, pretty good. I like it. I would say one thing, but like it's a minor convenience or like syntax choice. I would probably reduce even further the amount of keywords. For example, here. we have these keywords. I don't think you need, for example, the then keyword, because at the beginning when I was trying to write if statements, I was writing them like this. I think you could just use the do keyword everywhere instead of having a really like a specialized keyword just for conditions. That, in my opinion, like maybe that would be nice. And probably like even for these loops, like a singular form of a loop structure would be more than enough. For example, for infinite loops, you could like have a for with a condition, and then have do ends, or you could have a for with something like I and then this and then something, right? And then a do and end. Basically, what Golang does. So Golang only has like a one looping structure. So you could reduce the syntax of the language even further, and keep the same like semantic behavior. Yes, and I would probably actually add some form of match statement. So either a switch, right? Something like switch on, I don't know, or even a match. Like since this is a higher level programming language, we could match. And here, if I provide like a table, we'd have like something do. We could have like a case statement, and we could like match against different types of tables, right? Like I don't know how useful that would be, but it would be a possibility. And in that case, we would be like feature more or less, we'd have feature parity with Gleam, for example, or Haskell or any other functional language. But besides that, I like the language. I like the fact that this is the length operator. You just type the tally of the stuff. It reminds me of J and APL and those Iversonian programming languages, which is pretty good. Yeah, and that's basically, I don't even know what exactly this stuff does, to be honest. Oh, this is the variable. Okay, variable arguments. This is the string concatenation we already saw. And then, well, what does this do actually? Oh, the chunk stuff. Is it the chunk stuff? Oh, it's for the, yeah, this is for the table and list and all of that. Yeah. So, but yeah, I like the language. I feel like I want to build something with the language, to be honest. I really did like it. Let me think. Maybe I'm gonna revive the Dear Universe project. And I'm gonna do something with it, but with Lua. That's a possibility. Yeah, why not? Like the only thing that I don't like about Luajit is the fact that it is pretty much unmaintained. The last release was 2 years ago, and this guy is basically no longer really active on maintaining it, from what I understood. Yeah, it does not believe in releases. So yeah, do we have like a Luajit GitHub mirror? Well, he's still releasing stuff, right? He's still releasing stuff. Do I know what version I have? It doesn't give me. It doesn't give me the version. Oh, it's here. 2.1 point that. Okay. Okay. Well, it's fine. So yeah, I want to try this language. Maybe we can actually get some ideas from Lua for the compiler we are building. Maybe we can ditch the concatenative approach and do something like in this style with minimalistic syntax, but the language just feels nice and everything fits well together. But for that, I want to like have a proper project with Lua. So yeah, maybe I'm gonna revive the game or something. I need to think about it. So thank you for watching, and I'll see you in the next one.